Alright, hello there. This is Nathan Fikes, the DP3 Report presenter for Anteika-V. I'm going to give an entire overview of the design process for our gimbal, and I'll go through each step, mostly focus on the later steps, but I'll give a brief review on the previous steps here. So let's first go over the previous topics. So I'm going to give an overview about how this got started. So our team identified a problem on campus where students were unable to get access to very expensive equipment for photography, and we wanted to give them an opportunity through this gimbal to take all those very expensive items that they would exclusively get as a photographer and package them into one device that they can hold in their hands and they can use to help them assist in media capture. So for our mission statement, Anteika-V plans to provide an affordable, efficient, and excellent portable gimbal device that contains all the features necessary for professional media capture and be cost-effective in the market. So for our customer profile and use case, we use these to help us come up with internal ways that a customer would interact with the product. We used it as a way to figure out how would the product be interacted with, what would the product be doing, and it also helps out with the customer interviews that provide the customer needs that can help us define our specifications for our product. So for our customer needs and specifications, through our customer interviews, we've seen that weight, compatibility, appeal, or ease of use, stability, volume, and adjustance are of the highest customer needs that we need to set as criteria for our project. So before actually getting into the project itself, after we gathered all the customer needs, we've kind of gathered a general idea of where we're going to take this project. We can start going into how are we going to get this thing together in a way that will actually function. So we first start out as a functional decomposition. We take our project, this is going to be our project in the entire box here, and we're going to take energy, we're going to convert it using chunks or modules, and we'll use these modules inside the project as these sub-fragments, and we'll have solution fragments as well. So we'll have like a battery, light modules, a BLE, or a gyro sensor, motors, and these can all be decomposed into their sub-fragments and sub-solutions that we can then do some concept combination through our table here that we can present to other people through peer review to get a better idea of where we should head in this project. And one way we do that is with concept selection. After we've done the gallery method, we'll do our concept selection tables, and we'll put our projects as a team. We came up with 8 different unique projects, and we would take them down using this concept selection table where we compare it to a baseline and see which one satisfies the most customer needs. Alright, so for the fine line of intellectual property, we have to avoid infringing on a patent. So a very similar patent here that we've found is a cloud device or cloud platform device called the stand device that has a camera mounted on a rod that will stabilize a camera device on top. However, some of the features on this device are very important for product combination or concept generation. So some of the features on this device are a telescoping rod that will lock. For the Anteika-V gimbal, this will be an embedded feature underneath the main feature of gimbaling. The cloud stand device uses a joystick to modulate the camera on the top. Anteika-V's gimbal device will use a joystick in a similar way, but to change the direction of the camera on the gimbal itself. And a detachable C-clamp on the cloud device here is not actually used in our gimbal device. However, it's a very good way to increase compatibility between devices. When our device is being used, there's a possibility it can be failing. It It could fail in several different ways. So our team has developed an FMEA to figure out what would be the ways that this device could fail. So we would come up with internal ways to list our items here that could be potential fail modes. We would rank their severity, their occurrence, and their detection, and we would multiply these values together to get an RPN, or risk priority number, and this would be the number that we would use to prioritize our focus towards an FMEA failure mode. So of the four here, the two that are highest is the weather usage failure and mechanical failure. So in the weather usage failure, there's a possibility that the gimbal could be used outside, especially since one of our features was going to be a high power LED, and there would be a high risk of electrical shock using it in weather or moist conditions. For mechanical failures, there's a possibility that the 3D prints on here do not work, or the servos are not strong enough, or if it's used in an ill way, it could break. And usually camera devices are very expensive, so they would be on this device and they could fall, causing damage to users' devices, which is not wanted. So DFA and DFM. So the DFA is designed for assembly and the DFM is designed for manufacture. How can they guide our project and optimize our CAD models and optimize our assembly process? So manufacturing cost projection using the Boothroyd and Dewhurst handling insertion charts. So these are charts using the alpha and beta angles at which you insert a object into your project. For assembly, we're marked down here in this 30-step process. We've marked down each second that it takes to assemble these individual sub-assemblies and put them together. And we got an estimated time of 8.43 minutes of construction for the assembly. This real time, the actual assembly time was 10 to 12 minutes. That was very close to what we had projected. And the actual cost for production at a rate of $15 per hour would be $2.11. So this optimizes both the economics analysis, but it also helps with the BOM and this chart here, since it's laid out in a systematic way, optimizes how the product is assembled from the ground up. So we can detect where there could be a little bit of a nuance with actually constructing this device. If we had done it from the phone part itself, we started our project from the base and we would build up in a way that was easy to assemble. So the DFA helped us with that. With the DFM is a way to help you design products that can be manufactured in mass. So a CAD model here shows how one of the pieces in the gimbal was created in CAD, and it was designed in a specific way so that it could be manufactured in mass. So this type of thinking helps assist in lowering individual manufacturing costs. It provides a framework to assist in assembly. It also optimizes the CAD model for mass production. So keeping this in mind will keep our CAD model clean, but also keep it ready for mass production. Our BOM is built on our CAD, or our CAD is built on our BOM. So when we keep track of a bill of materials, it's easing the implementation of CAD and ultimately allows Anteika-V to realize the final project. So the benefits of having a CAD based on the BOM is that we have an exact representation of our product in computer, and we can help with an economic analysis where we have the BOM, we have every single part listed in the BOM here, and we have all their part numbers and their prices. It helps with top-down assembly. We have all our parts needed to assemble our entire product, just one of them, and we have all the prices needed to calculate what would it take to make one product. And this is actually used as a value in our economic analysis. This also assists in the DFM and the DFA, where we're using these parts, and we can help it in the DFA where we can include the part numbers in the assembly process, and the cost here helps with DFM. Actually, no, not the cost. The actual design of these parts through the CAD, help with the DFM for manufacturing. All right, so this is our final product. This is what was the product of all the design process iterations. And we did have to unfortunately postpone some features, but this was based on the FMEA. The stable implementation of a gyroscopic sensor was not able to be used because the sensor was too sensitive, it was too unstable. It would cause an FMEA failure, which we didn't want, so we would postpone it to a V2 of the gimbal. Smarter and compact wiring, where we would use wire swivels or embossed bodies to keep the wires within the housing for better use in weather environments. Housing shell would help with that as well. A reduction from parts from 23. So we have 23 unique parts on this device. Some are modules, some are part of a sub-chunk in there. We would like to reduce the amount of parts so that it's easier to assemble, lowering manufacturing costs, and it'll be easier for the production of a gimbal. Since our gimbal is marked around $140 in the market, any way to reduce the manufacturing cost is a good thing. And high power LED kind of stems off the FMEA, the FMEA analysis, where the weather conditions could cause a shock to components that could cause damage to the body or to the components itself. So, in conclusion, what has Anteika-V gained as a team through the product development process? Well, we've gained a concrete method to iterate and improve. These are from the concept generation, where we had iterative processes where we'd mesh together concepts. We would have them peer reviewed by team members outside of our team. The DFA, the DFM, and the FMEA are ways to iteratively look at a project, see what could go wrong, for instance for the FMEA, and the DFA can help us figure out what it would take to manufacture one of these products. It can help us go back on the process, think about how we're going to build this. Ethics and economics. Economics is a always ongoing process that we always look back on, and ethics kind of ties in with the FMEA. We have gained ways to properly product manage through the Gantt chart, through assigning tasks, making them parallel if we have them on a critical path. The DSM helps to represent that in a better way. We've learned how to use memos, and we've done DP reports. We can reflect back on our project using these methods. And we've gained some platforms to plan and execute through the QFD, where we take all our target specifications from customers, customer needs, and we can plan them as criteria for how the product is going to be made. The BOM is a way to keep track of every single aspect of the project, and it helps with the CAD, where we can have an exact representation of the product in computer, so we can have additional additions to the project without having to fiddle around with the real product. So, you've seen it here. Here's the actual product we've made for our project. It is the gimbal. It's not powered on right now, but it is using all the processes used in the product development process through 3D printing, custom parts, ordered parts, very standard parts. Some use special circuit components, but overall it should meet all customer specifications needed of our customers. Lastly, to wrap this up, I'll just go over the Anteika-V's memo here. Anteika-V, stabilizing the future of cutting-edge photographic technology at the palm of your hands. All right, thank you.